So hello and welcome back. So we have another question related to properties of exponential functions. So basically the question is, when Nira sent a chain letter to her friends asking them to forward the letter to more friends. So it's just the same example that we did in the beginning of this section, probably. The relationship between the elapsed time, t in months, so t is basically in months, t in months. Since Venera sent the letter and the number of people, p of t, so p of t is the number of people who receive the email, is modeled by the following function. So the function is p of t is equal to 2 raised to the power 3t plus 7. Every month, now we're supposed to answer this question, which is every month the number of people who receive the email is multiplied by a factor of something. So it's asking about the common ratio of this function, and but the common ratio is not, the function has not been written in a proper form, so you cannot really call this the common ratio of the function. If the function was in the form, for example, p of t is equal to something multiplied by, for example, 2, like this, and then raised to the power t, then this number has been raised to the variable, to the input of the variable input of this, or input variable of this function. So now you can call this the common ratio of the function, because every time you increment this t, the function is, the output of the function is multiplied by another factor of this number. What I mean by that is that, for example, if you have a simple table here, when t is equal to 0, your output p of t is equal to a, because 2 raised to the power 0 is 1. When your t is equal to 1, then your output is a times 2. When your t is equal to 2, your output is a times 2 times 2. When t is equal to 3, your output is a times 2 times 2 times 2. So every time you increment your input, your output is multiplied by another factor of this number, which is your common ratio, one more time and one more time and one more time. So now this you can call it the common ratio, which has been raised directly to the input variable of the function. But here you can see the input variable has been mixed with other things. It's not just the variable, it's a whole expression. So in order to solve this problem, because the problem is that here the question is every month. Every month means that you're supposed to have only t as the index, because t is also t here is in months. So when you ask every month, means every time that you increment t one more time. So basically then here you're supposed to have only t as the index of this number. Otherwise, when you increment t once, basically increment t by 1 here, for example, then the whole, for example here, if t is equal to 1, what happens is that then this whole index becomes 3t plus 7 is equal to 3 into 1 is 3 plus 7 is 10. So your you're multiplying 10 factors of this 2 by the output of the function. Now if you increment t by another time, once more, then 3t plus 7 becomes 6 plus 7, which is equal to 13. So you're again, by incrementing t once, you are increasing the number of the factors by 3, not by 1. So that's the problem here. So in order to solve that problem, I need to change my function in such a way that I need to change the form of this function in such a way that I have only t as the index of this number. So the function is p of t, the current form is p of t is equal to 2 raised to the power 3t plus 7. So this is all about the properties of exponential functions. So let me see. So here maybe I should have told you about the properties of exponential functions before we started this part, but that's not a problem. We can manage that as well. So basically there is something there is a rule of exponential functions that says a raised to the power b plus c can be written as a raised to the power b times a raised to the power c. If I'm not mistaken, most probably I'm not. So p of t, based on this, so you can basically separate these two. You can write this as 2 raised to the power 3t into 2 raised to the power 7. So 2 raised to the power 7. So 2 raised to the power 7 is whatever, something, which becomes your initial value of the function. So I rewrite this as p of t is equal to 2 raised to the power 7 times 2 raised to the power 3t. Now this is your initial value, whatever the value might be, I don't know. 2 raised to the power 3t is now the term that contains the variable, but still I need only t here. So what I need to do is I can write this as, I told you in the previous video, I told you about if you have a raised to the power b whole raised to the power c, you can write this as a raised to the power b times c. So basically now I have a raised to the power b times c here. I can write it in this form. So I can write this as p of t is equal to 2 raised to the power 7 times 2 cube whole raised to the power t, based on this rule. So basically this part is just like this part. This is your b, this is your c, and this is your a. And based on this, I'm just rewriting this as this form. So it's 2 cube raised to the power t. So now what is 2 cube? 2 cube is 8. 2 cube is 8. So I can write this as p of t is equal to 2 raised to the power 7 times 8 raised to the power t. And so now this is the beginning, the initial value. And now you can simply form a table based on this. Based on this, you can form a table. And you have your t here and p of t here. When your t is equal to 0, you get 2 raised to the power 7, the number of bacteria, I suppose it was, I don't know. No, the chain, that was a chain letter problem, I'm sorry. When your t is equal to 1, you have 2 raised to the power 7 times 1 factor of 8, because it's 8 raised to the power 1. When your t is equal to 2, it's 2 raised to the power 7 times 8 times 8. When your t is equal to 3, it is 2 raised to the power 7 times 8 times 8 times 8. So you can see, as you're increasing the time here, more and more factors of 8 each time is being multiplied by the output of the function. So 8 is basically now the common ratio of this function. And so every month, now that I know that every month, so for example, every month means after 1 month, 1 factor of 8 is being multiplied here. After another month, another factor of 8 is being multiplied here. After another month, another factor of 8 is being multiplied here. And so every month, the number of people who receive the email, this is the number of people who receive the email, is multiplied by a factor of 8. And that's basically the answer to the solution here. So thank you, and I'll see you in the next video. Thank you.